Now it's recording, okay? Hello everyone, my name is Claudio Silva and this is lesson number 1 on laptop course, okay? This lesson I will give you for free, okay? Because our colleague Adrian is there, okay? And we are repeating this lesson because lesson number 1 I did not record it, okay, this lesson, but this one I will record it and send it to our colleague Adrian, okay? So I will repeat this lesson for him, okay? So once again, welcome all to lesson number 1, and I hope you have a good time, okay? That you will enjoy a good time, okay? So let's start. As always, okay, in all my course I start always with the block diagram, okay? Let me just close this right here from team view that is still in part, okay? As always in all my courses, okay, in all my teachers, I always start with the schematic of the motherboard that I will teach, okay? So and let's start, okay, by talking about the VIN, okay, voltage input circuit on motherboard, okay? In this lesson I will only talk about 19 volts, okay? Second lesson I will talk about 3.3 volts and 5 volts, okay? In the end of this lesson you will know everything about 19 volts on motherboard, okay, on laptop motherboard. Lesson 2, everything about 3.3 volts and 5 volts, okay? Why? Because people tend to mess around, okay, and mix, okay, 19 volts with 3.3 volts and 5 volts, okay? No, let's separate, okay? Let's so you can have a study, okay, separate, okay? So you can have notes about 19 volts and notes about 3.3 volts and 5 volts, okay? Deep notes, okay? So this 1 hour I will only talk about 19 volts, okay? All the voltage, all the measurements I will teach in this lesson, okay, are only based in 19 volts, okay? So we have here in image, okay, the block diagram of a Acer 5517 project AMD. So we can see on this left side, let me just use my pen, okay, use my pen. We can see here on this bottom left side right here, okay, all the pages concern to power supplies, okay? In all schematics the last pages are always concerned to power supplies, okay? Like here, let me just show you here, okay, this CPU right here, okay? We have page 6, 7, 8 and 9, okay? Page 8 and 9 are power supplies, okay? GMCH, we have page 12 to page 16, okay? Page 14 and 15 and 16 our power supplies, okay? GMCH, this BGA, it's 18, 19, 20, 21 and 22, okay? Pages 20, 21, 22, okay, are power supplies, okay? So so in the schematic, okay, globally speaking, okay, the last pages of schematic, it's for power supplies, okay? When we see, for example, okay, this CPU 6, 7, 8 and 9, okay, this 6, 7, 8 and 9, okay, this 8 and 9, okay, it will be concerned to power supplies, always the last pages, right? So here we have page 37. Where's the mouse? My touch, here, okay, I'm sorry, I'm always losing my touchpad, okay? Here we have page 37. Let me just zoom it, okay? Page 37, okay, and then we have 14 to 48 here, 14 to 48, okay, the last pages on our schematic, okay? It's concerned to power supplies right here, as we can see, okay? So let's start, okay, with our power jack, right? As you might know, okay, here we have our converter, okay? This is called a converter, okay? That's why on the LVDS circuit we have the inverter, okay? Because it's the opposite of converter. This is a converter. This is connected or plugged to a 213 volts AC, okay? Here in Portugal we use 230 volts. Okay, some countries use 110 like USA, Brazil, and others 220. Okay, here in Portugal we use 230. Okay, so here we have our converter. Okay, this is GND and this is GND. Okay, this is a inductor. Okay, this is L from inductor. Okay, this is the converter. Okay, and this is the plug. Okay, and this is the plug. Okay, so let's start. When we supply the board with this voltage, okay, that goes around 15 volts to 22 volts, okay, I will use 18 volts, okay, as reference. Okay, this 18 volts, it is not a fixed voltage. Okay, it's for reference. We found 15 to 22 volts. Okay, I'm only using 18 volts for my calculation and for reference. Okay, so when we supply this board, this ASA 5717, okay, with this 18 volts right here, okay, we can measure it in pin number 1 right here. Okay, and this is PJP1. Okay, power jack 1. Okay, this is PJP1. Okay, we will find this 18 volts on pin number 1. Okay, so when we talk about these converters, okay, we have to have in our mind, I'm sorry, need water. We need to have in our mind two things. Okay, the quality of this charger. Okay, and we need to take attention. Okay, all these input circuit right here. Okay, this circuit right here, it is called a low pass filter. Okay, I will explain what is a low pass filter. Okay, but why the quality of the charger it is so important? Okay, people tend to use these Chinas. Okay, 15 volts to 24 volts. Okay, that chargers, okay, are not good for end up customers. Those chargers, okay, are good only for testings, okay, because the quality of the charger, let me just see right here. Okay, normally we will have 90 watts, sorry, 90 watts, we will have 90 watts charger, okay, or 65 watts charger, okay, or 65 watts charger, okay, or 65 watts charger. Okay, this input right here, okay, this ADP in, okay, alternate direct, let's see right here. Okay, just continue, sir. Okay, right here. Okay, so this ADP in, okay, means alternate direct power input. Okay, this VIN voltage right here means voltage input. Okay, I will and we will see this voltage in. Okay, let's start with this alternate current direct current power input. Okay, and why it is called ADP in. Okay, so most chargers we will find with 19 watts and 65 watts. Okay, and we have a voltage input of 18 volts. Okay, of 18 volts, right here. Okay, but now listen, what burns these capacitors right here? Okay, it is not the voltage, okay, it's the current. So we know that we have a 18 volts and 65 or 19 watts. Okay, so watts, it's written with P, okay, not W. P, this is potence, yes, okay, potential, this is potential, okay, in English this is potential. Okay, so we say that potential equals to voltage, okay, times or multiplying, okay, by current. Okay, by current we have 18 volts and we have our potential, okay, watts, 19 or 65. Okay, but we don't have our current. Okay, we don't know the current in this circuit right here, okay, in this low pass filter. So if potential equals to voltage times current. Okay, now that means that current equals, okay, 2 watts P divided by the input voltage. It means that input voltage, okay, so this is equal, okay, as 90 or 65, let's use 90, okay, we will have 4 amperes, okay, divided 18, okay, we will have something like 4 amperes, okay. So 19 watts divided by 18, okay, 5 amperes, okay, 5 amperes, okay. So here in this input, okay, we will have 5 amperes, okay. 4 volts, it's 19, okay, 19 volts instead of 18. Oh, sorry, lost my calculator. Let's open again, okay. Sorry, let's start from the beginning, okay. 19 divided by 90 divided by 19, okay, 4.7, okay, 4 point something amperes, okay, right here. As we have 18 volts, okay, we will have here, okay, 5 amperes, okay. Okay, now let's see the quality of this charger, okay. Why it is not advisable to use these Chinese, okay, these multi-voltage chargers, okay, because these multi-voltage chargers, okay, they are made to function from 15 volts to 24 volts, okay. Their fuse inside, it is made, okay, to blow at 24 volts, okay. Now imagine that that charger is faulty, okay. This is 19 volts, okay, but the fuse on that charger, it will not blow. Why? Because this supply right here, okay, this ADP in, it's 18 volts, 19 volts, okay, but the fuse on that charger, it is made to blow at 25 volts, so it means that it will let that voltage pass, okay, normally. So this 18 volts right here, so this voltage input right here, okay, it will be more, okay, it will be more than 18 or 19 volts, okay. And let's never forget, okay, all the calculations, okay. People tend to forget the calculation, but remember, all these components are here because there was a previous calculus, okay. The engineer calculated all this circuit right here, okay, based in calculus, okay. And the engineer, when made all this calculation right here, said, okay, we need to have here, okay, 16 watts or 19 watts with 18 or 19 volts, okay. So we need to have a current of 5 amperes or 4.7, or if it is 16 watts, it will be 3 point something amperes, okay. So for all this circuit right here to work properly, we need to have this voltage with this, okay, this voltage with this watts and with this amperes, okay. Voltage, amperes and watts, okay, it will make this circuit right here to function properly, okay. So that is why when a customer comes to me with a charger from Chinese, okay, I always say to him to buy a proper, okay, a original HP, Asus, Acer, Dell, okay, charger. It might be expensive. It might be expensive. Okay, here in Portugal it's 50 euros. 60 euros, okay. It might be expensive for a charger, okay, but a charger it's less expensive than a brand new motherboard, okay. That is what I explained to them, okay. So here we have the PC1, PC2, PL1, okay. Let me just close my Facebook, okay, because I'm recording this lesson and people are, let me just close my Facebook, okay, Facebook, not Facebook, my Skype, okay, because I'm recording, okay, and then it gets all dirty images, okay. So continue. We have this low pass filter, okay, and it is PC1, it is PC2, PL1, okay, PC3 and PC4, okay. This P right here, it means power, okay. All power. Why power? Because it belongs to a 19 volts line, okay. All components that belongs to a 19 volts line, okay, it all start with P, okay. That's why we have PQ, PU, okay, PR, PC, okay, because that component belongs to a VIN line, okay, 19 volts, 18 volts, okay, whatever. Here, okay, this C means capacitor, okay, this P, right, this C means capacitor, okay. This PL1, it's a power inductor or power coil, okay. So why it is coil and it is represented with L, okay, because the C coil, C is already given to capacitor, okay. The C belongs to capacitor, okay. So for to not make any confusion, we have C belongs to capacitor and L belongs to coil, okay. Coil, that L, that final L, okay, coil, and it's power coil 1, okay, right here. So pin number 1 of our DC jack, pin number 1, it's the input pin, okay. Pin number 2 and pin number 3, okay, are the GND, okay. We have the capacitors PC1, PC2, inductor PL1, capacitor PC3 and capacitor PC4, okay. Here we have 560 picofarads, okay. This is P, this is pico, okay, and this is 50 volts, okay, 50 volts right here. The same right here, okay, 12 picos, okay, 50 volts, okay. Capacitors, okay, when they are in parallel, they sum, okay, their values sum, okay. So you so it's PC1 plus PC2, okay, or we can say 560 plus 12, okay. This value right here, okay, makes a unique capacitor, okay. This makes a unique capacitor, okay, right here, and this is the same, 12 plus 560, okay, right here. So this 18 volts, it will arrive on this motherboard, okay, as being ADP in, okay. Why it's ADP in, okay, because A, it's alternate current. But you say, but Claudio, how can you say alternate if if this is 18 volts DC, okay, not AC? Why is this A right here, okay? This A right here is to remind us that we can find any alternate components right here, okay. How? If this charger fails, okay, this charger tends to fail, okay. It is from the HP, okay. It is original or a fake one. It is original or these China ones, okay. This charger tend to fail, okay. So the schematic reminds us, okay, let me see my touchpad, okay, it's here. So this schematic reminds us, okay, with this A, alternate current, and then it says direct current, power in, okay. So let's see how it works, okay, this filter and this alternate current, okay. As you may know, okay, direct current has no frequency, okay. Better as a very low frequency, okay. Direct current have a very low frequency, okay, but alternate current have a high frequency. So this is a low pass filter, okay. This is right here, it is called a low pass filter, okay. As the name says, it only let pass low filter. low frequency, okay, because this filter right here, okay, composed by PC1, PC2, PL1, PC3 and PC4, okay, it will filter all high frequencies. Okay, so if by some error, okay, some faulty, this charger right here lets some alternate component pass through here, okay, on pin 1, all this filter right here, PC1, PC2, PL1, PC3 and PC4, okay, it will filter that high current, sorry, that high frequency, okay, not high current, okay, high current burns this, okay, it will filter this high frequency, okay, that is why it is called a low pass filter, okay, it only will allow the passage of low frequency, okay, that is why we have here this filter, okay, this filter it's not a active filter, okay, it's a passive filter. Passive filter, why? Because it only functions when there's high frequency, okay, as we have here 18 volts DC on oscilloscope, you will have a straight line, okay, a straight line. AC on oscilloscope, it's one sinusoid, okay, it's one sinusoid on oscilloscope, right, because these have high frequency, okay, and this have okay a very low frequency, okay. When this high frequency by somehow escapes from this charger, okay, this high frequency, it will be present here, okay. What it will happen, it's when this wave, okay, when this wave goes this position, okay, it will be filtered by PC1, okay, and the remain, it will be filtered by this PC2, okay. The remain, even though, okay, the remain, it will be filtered by PL1, okay, and if some noise, okay, some dirt, some high frequency, okay, gets passed by PC1, PC2 and PL1, okay, if, okay, it will be filtered by PC3 and it will be filtered by PC4, okay, but and we will have this VIN line a completely clean straight line, okay. This is not a active filter, okay, this is called a passive filter, okay. Why? Because it only will work when some AC component is present, okay, that is why it is here. The charger itself has a filter right here, okay, this inductor, it's here to filter, okay, but by some mistake, some fault, some error, okay, if these AC components, okay, get through the charger, get through the inductor, okay, the computer, the motherboard itself, it will have this filter at this point, okay, at this point right here. So, and we will have this VIN voltage, a straight line on our oscilloscope, okay. If you measure here with your oscilloscope and you see some noises, okay, we call noises the electrical noises, okay, it's when you measure and you see some peaks, okay, some distortions, distortions, okay, distortions online, okay, you see something like this, okay, this is called dirt, this is called noise, okay, this is called noise, okay, or it is called a smooth ripple, okay, better, or it is called a smooth ripple, okay, a smooth ripple, it's a straight and clean line, okay. This is called noise, this is called noise, this is called dirt, okay, this is called dirt, okay. And when you measure it, we are here where it says VIN, you need to have a straight and clean 18 volts DC presented on your oscilloscope, okay, right here. So next, VIN voltage, this VIN voltage right here, okay, it will be taken to this point of the schematic, okay, this point of the schematic, VIN voltage right here, okay. So this VIN voltage, it will go through PR40, PR33 and PC44. Okay, this is a filter. Okay, this will filter the current. Okay, right here. So this fin voltage, it will present on this PQ. Okay, it's P because it's on a VIN line. Okay, 18 volts line, PQ7 and PQ8 right here. Okay, this is the in Portugal we call the entrance MOSFET. Okay, I don't know the term in English. Okay, because this circuit, okay, we call this this VIN, this first circuit on computer. Okay, we call the entrance circuit. Okay, I don't know how they say in English. Okay, but in Portugal we call this the entrance circuit. Okay, so this is the first MOSFET and this is the second MOSFET. Okay, and they are both PNP. How can I tell? Okay, only looking for the schematic, how can I tell, how can I be 100% sure that this is PNP and not NPN? Okay, because of this arrow. Where's my okay, yeah, because of this arrow right here. Okay, because of this arrow will always point to the positive side. Okay, always point to the positive side. Okay, so this arrow right here, okay, it's pointing up, meaning that this P and this is P. Okay, because the arrow is pointing up. Okay, P. Okay, so if this P and P, so the gate it's N. Okay, this is drain, source, and this is gate. Okay, so we have this PNP MOSFET. Okay, same here, it's pointing up. This is P, this is P. Okay, and this is N. Okay, this right here, it is not an error. Okay, this is a diode, the internal diode. Okay, this is internal diode. Okay, another method so we can use to detect if this is PNP or NPN, just looking for the schematic. Okay, the number right here, the number, okay, 0707. Okay, every time a MOSFET ends with a non-pair number, okay, it's always PNP. When a MOSFET ends with a pair number, it's NPN. Okay, always. Okay, you can see on the schematic. Okay, but in some motherboard schematics, okay, you will not be able to see the interior. Okay, so another method, okay, that I use, it's always look here, okay, for this end number. Okay, this ends in 7. Okay, this is a non-pair number. Okay, meaning that this is PNP. If this ends up in 6, okay, 6, this arrow would be point down. Okay, showing that the gate is positive. Okay, and it would be a NPN. Let me see if I can show you. Okay, right here, let me just see if there's an example right here. Okay, you see right here, this is pointing down. Okay, it's pointing down, it's pointing down, and you see all ends up in 6, ends up in 6. You see right here, ends up in 6. Okay, it's pointing down, meaning that this is P. Pointing down, meaning this is P. Okay, this is pointing up. You see right here, PQ9, it's pointing up, meaning that this is P. Okay, meaning that this is P. Okay, now look, this is pointing up, PNP, ends in 7. This is pointing down, ends in 6. It's NPN. Okay, it's NPN. Okay, memorize this. Okay, memorize this because it will be very helpful for you. Okay, because we need to have, okay, all this knowledge, okay, about PNP, NPN, bipolar, okay, transistors in English, transistors. Okay, right here. So let's make a pause and let's talk about the battery. Okay, then I will restart, okay, to that point where the battery and the VIN can get together and become B plus. Okay, I will stop that teaching. Okay, so let's see our battery right here. Okay, so this is battery. I'm sorry, need water. This is battery connector. Okay, with the name of power jumper 2. Okay, PJP2. Okay, so we can see, okay, 9 pins. Pin 9, 8, 7 and 6, okay, are G and D, okay, also known as ground. Pin 1, okay, what is this pin 1? This pin 1, okay, it's the positive voltage that it will be taken to the charge MOSFET, okay, through this PL7. Pin 2, what is pin 2? Okay, this is the communication signal that will take and bring all the communication to PJP3. Okay, pin number 3, it's the sensor pin. Okay, it's the temperature sensor pin of battery. Okay, this signal it will be taken to KBC. Pin 4, okay, it's pin 4. Okay, let's just where's my mouse? Okay, it's here. So pin 3 right here. Okay, let me just, okay, show you. Okay, this is the battery temperature. Okay, pin 4, it's the clock. Okay, it's the clock, and I will explain what is this signal and what stands for. Okay, and this is data. In motherboard, okay, we will find two different types of clock. Okay, the working clock and the synchronism clock. Okay, the working clock you will find, okay, as a sinoid right here. Okay, this is from Crystal. Okay, 25, 14, 48, 32. Okay, this is from Crystal, but there's a second clock on motherboard. Okay, it is called the synchronism clock, and that clock always work with data. Okay, as we see right here, pin 4 and pin 5 are data and clock. Those pins right here, as you might know, okay, battery from computers are not just simply batteries. Okay, like a car battery, okay, like most batteries. Okay, they are called smart batteries. Why smart? Because they have the ability not only to charge the computer and receive charge from computer, but to communicate with computer. Hey, listen, I'm 15%. Hey, listen, I'm 100%. Okay, hey, listen, I'm out of the computer, I'm out of the laptop. Okay, so there is a communication between the battery and the computer. Okay, so that communication is made by two circuits. Okay, circuit from battery and circuit from computer, right? So they communicate each other. And how? With clock and data. Okay, we will have data. Okay, let me just, okay, we will have data. Okay, right here, this is data. Okay, watching with our oscilloscope, this is data. Okay, and this is the synchronism clock, a square wave. Okay, we will have a square wave on our oscilloscope. Okay, can you see the differences between the working clock? It's a sinoid, and here, okay, this is a square wave. Okay, right here. And how this function? Okay, let me just giving you an example why the synchronism clock and the data needs to be always together. I'm teaching you, okay, for about half an hour, right? And I'm speaking with time. Okay, my time and my voice are together. Okay, now imagine that I stop talking. The time will continue, but there is no sound. You see? Okay, so you have time, you have clock, but you don't have data. Okay, you will not receive knowledge in that time. Okay, but there was time. Yes, there was clock. Your clock on your wrist, okay, it continues, but I am shutting down. Okay, I am shutting down my mouth. Okay, there are no words going out from me. Okay, so you are not receiving. Okay, and then you say, hey, Mr. Fiti, how are you? And I say like this, hey, Sr. Fiti, how's your baby? How's your wife? Okay, so you send an information to me, okay, but you did not receive any data from me. Okay, now imagine that you have data but you don't have clock. Okay, it will be like that little guy from Star Wars, that Obi-Wan Kenobi or something like that. Okay, that guy, that gray guy, okay, that when he speaks, okay, he changes the words. Okay, we used to say, I'm going to ride on that bicycle. Okay, uh, him, that bicycle I will ride. Okay, something like that. Okay, his words are not in time. Okay, it's like I come here and then I start saying okay, there was data but that data is confused. Okay, why? Because there is no time. Okay, it's like I came here and speak too fast. Okay, some kind of English with Portuguese. Okay, with awful English mixed with Portuguese. Okay, you would not understand anything. Okay, so I need to stop and pause, stop talking. I need to talk with time. Okay, I need to take my time. Okay, that is why the clock and the data need always to be together. Okay, as you can see as bias. Okay, you will have in bias the synchronism clock and the data. Okay, data output and data input. Okay, KBC, you will find this synchronism clock and data. Okay, because this information needs time, okay, to be comprehensible. Okay, that is why we have this pin 4 and pin 5. This pin 4 and this pin 5, it's the communication pin. Okay, if you insert the battery and the computer shows that there is no battery inserted, okay, you need to start looking for this pin 4, pin 5. Okay, serial clock and serial date. Okay, because it's these two pins that will inform the computer that the battery is inserted. Okay, is actually inserted. Okay, right here. So yes, okay, so continuing, after we see the DC jack, after we see the battery connector, okay, and all pins, okay, the computer, it will need a signal informing that the DC jack and the battery are inserted. Okay, so the signal that will tell the computer that the DC jack is actually inserted, it's this signal right here that it will be sent to KBC with the name of AC in. Okay, AC in. Okay, right here. So as I have told you in the beginning of this class, I will only teach about 19 volts on this lesson. Okay, so that means that everything in this lesson it's with 19 volts. Okay, right here. So we have this V in voltage. Okay, we have this voltage supply, VS, this voltage supply. Okay, one more thing. Okay, we have two types of VS voltage, before start and after start. This VS voltage before start means voltage supply. VS voltage after press start, okay, means voltage suspender. So we have this VIN voltage right here. Okay, this is a comparator. This is called a comparator. Okay, or an amplifier. But just to simplify, okay, I will not talk, okay, about his amplification, okay, but I will talk about the commutation. So this is sorry, I dropped something here. Okay, I dropped something here. This is a comparator. Okay, what is this function? Okay, whatever. What this component do? Okay, what this component do? Okay, very simple. Okay, he will compare values. Okay, this is a comparator. He will compare values. Okay, the pin number 3, the plus pin, means means inverted. Sorry, means not inverted pin. Okay, not inverted pin. The pin 2, okay, the minus pin, okay, means inverted pin. Okay, so this comparator it will compare values. Okay, so when pin number 3, when the value of volts on pin number 3 is bigger than the pin number 2, okay, we will have on pin number 1 voltage. Okay, right here, let me just use one logic. Okay, one logic, okay, binary number 1 and 0. We will have right here 1, okay, voltage. If pin number 2 it's bigger, the value of voltage of pin number 2 is bigger than the pin number 3, okay, so we will have in here no voltage, 0 volts. Okay, because this component is a comparator, he will compare both values. Okay, so in here we have this RTC, real-time clock voltage reference. Okay, this one right here, it's with 3 volts from battery CMOS. Okay, this 3.3 volts. So when there's no VIN voltage, okay, remember that this AC in, it will inform, okay, the computer that the DC jack it's inserted. Okay, so when we have no VIN voltage, why? Because there's PL1, okay, damage, there's some faulty, on the entrance circuit, okay, on the input circuit better. Okay, so this VIN voltage, okay, it is not present in here. What it will happen, the RTC V reference, it will be present on pin number 2 with 3 volts. Okay, pin number 3, it will have 0 volts. As 3.3 volts is bigger than 0 volts, pin number 2, okay, it will have a high value comparing with pin number 3. So there is no AC in on motherboard. Okay, the motherboard, it will not receive the information that the DC jack is plugged on the computer. If everything is working fine, okay, and the VIN voltage is present here, okay, so we will have this where's my touchpad? Okay, right here. So we have this voltage divider right here. Okay, we have this voltage divider right here. Okay, so we have PR4 and PR7. Okay, the drop voltage in here, in this PR4, okay, the drop voltage in here, it will be present in here. Okay, it will be about 8 volts something. Okay, just wait. Okay, let's see, we have voltage, okay, we have resistance, okay, resistance is PR4, yes, PR4 plus PR7, okay, plus PR7, okay, let's, okay, resistance total, okay, it will be 84.5 K, okay, this is K, okay, this is K, K means 1000, right, K means 1000, we have ohms, okay, we have ohms, then we have above, okay, I'm going to write in here, okay, under, but it's above, okay, it's above, we have kilo, that means 1000, okay, that's why we have kilometers, okay, it's 1000 meters, we have kilograms, 1000 grams, okay, this is kilo, 1000, and then we have mega, okay, or kilobytes, megabytes, mega is 1,000,000, 6 zeros, okay, okay, we have kilo, we have mega, okay, then we have giga, okay, and then we will have tera, okay, tera. So this is 1000, okay, so when we see here 84.5, okay, we see here 84.5 thousand ohms, okay, this is 1000, okay, this is 1000, okay, this is K, okay, this is not ohms, plus this 20K right here, okay, this 20,000, okay, is 20. Okay, okay, it is not much math. Okay, this 100. Okay, and 4.5. Okay, thousand exponential 3. Okay, this exponential 3, okay, means 3 zeros. Okay, means these 3 zeros. Okay, exponential 6 means 6 zeros. 1 2 3 4 5 6. Okay, means 6. This exponential 3 right here, okay, means 3 zeros. Okay, if it was minus 3, okay, then it would be 3 zeros here in this position. Okay, right here, but it's no minor. Okay, this is 3. Okay, let's just use my calculator. Okay, because I don't like Windows calculator, I rather my own. Okay, so we have 84. Sorry, calculate now. We have it's 100. Okay, there is no calculation needed. Okay, so let's see our current. Okay, our current, as you might know, okay, it's voltage. Okay, total resistance. Why it is total resistance and not just one resistance? Okay, because when we have resistance in series like this, okay, the current that cross all the resistance in series, okay, it's the same current. Okay, it's the same current. Okay, it's the same current. Okay, there is no variation of current, only voltage. Okay, resistance connected in series, the variation is in voltage. Okay, the current is the same, so I need to calculate the current between the current that it will cross PR4 and PR7. Okay, the current is the same, so I need to calculate, okay, the total resistance of this circuit right here. So this is why I have here, okay, resistance total. Okay, this is in Portuguese. Okay, we call this resistência total. Okay, or resistance or total resistance in English. Okay, so nothing much. Okay, this is VIN. Like I've told you, okay, this lesson is all about 19 volts. Okay, there is no voltage besides 19 volts. Okay, so we have here 18 or 18, 19, 19, that's 19 volts. Okay, 19, okay, divided by 104.5, okay, exponential 3. Okay, let me just use my calculator. Okay, my handy calculator. Okay, not the Windows one. Okay, 19 divided by 104.5. Okay, exponential 3. Okay, and we have 1.8. Let me just, where's my mouth? Okay, and we have 1.8 milliamperes. Okay, and we have 1.8 milliamperes. Okay, crossing this circuit right here. Okay, right here. So we have our current right here, okay, crossing PR4 and PR7. Okay, let's now see how many voltage we have here. Okay, because this is the voltage at this node that we will see present on pin number 3. Okay, it's this voltage right here that it will cross PR6. Okay, with 22K, it will be present on pin number 3. Okay, so let's see. Okay, I will call it as voltage drop. Okay, V voltage and D drop. Okay, I will call it voltage drop. Okay, it will be, okay, the value of PR4 84.5. Okay, okay, multiplying by current. Okay, 0.08, okay, minus 4. Okay, let me grab my calculator again. Okay, 84.5. Sorry, let me just calculate again. 84.5, okay, 3, 84.5 times 1.8 exponential minus 4. Okay, 15 equals to 15. Okay, equals to 15 volts. But remember, on pin number 3 we will not have this 15 volts. Okay, let's just grab my microphone. In this pin 3 we will not have this 15 volts. Why? Because we have calculated here the voltage drop. Okay, this is the voltage drop. Okay, so this is the amount of voltage that PR4, okay, it will cut. Okay, it will absorb. Okay, that is the amount of voltage. So now let's see, okay, our voltage. Where's my pen? Oh, it's right here. Now let's see the voltage that we have. Okay, so we need 19 volts, sorry, minus the voltage drop. Okay, the voltage that the PR4, okay, it will suppress. Okay, this voltage, it will not pass through PR4. Okay, this 15 volts, nothing much. Okay, we will have 4 volts. Okay, we will have 4 volts. So in pin number 3 we will have these 4 volts. Pin number 2 we will have these 3 volts. Okay, as this is a comparator, okay, we will have on pin 2 3 volts from RTC voltage reference, and in pin 4 we will have 4 volts. Okay, as 4 is higher than 3, okay, on pin number 1 of this PU1A we will have, okay, this signal, this one logic, this signal named AC in. Okay, if by some faulty, okay, on PR4, PR7, PR6, PC1, PC2, PL1, okay, if there's some error at this point, okay, we will not have AC in present. Okay, and the computer, it will not receive the communication, okay, indicated that the DC jack is plugged on motherboard. Okay, so this RTC voltage reference, it will come, okay, from PU2, okay, right here. Okay, you see right here, okay, with 3.3 volts, okay, right here, coming from the CMOS battery. Okay, so continuing our analysis. Okay, and now we have this signal right here named the main power on. Main power on here, okay, that goes to page 8 and page 39. Okay, page 39 it's the 3.3 volts and 9 volts. Okay, as I have taught on the beginning of this lesson, the end pages of the global schematic, it will be concerned to the power supply, to the global power supplies of motherboard. Okay, so this page 39 is one of the last pages and is concerning to 3.3 volts, right? So we have here, okay, another comparator, right? So what is the difference between this comparator and the other one? The other one, it will receive the VIN, okay, and it will send the information that the DC jack is plugged. Okay, this comparator here, okay, the PU5A, what it will do, okay, it's simple. compare the values, okay, because it is a comparator. It will compare both values right here, okay. And if the pin number 1 is higher than the pin number 2, here we have one logic, okay, or we will have voltage. If pin 2 is higher than pin 3, we will have zero logic, no voltage right here, okay. Then it will cross this PD9, this security diodes, okay, and it will active this PQ21 right here. When this PQ21 right here is active, it will kill this main power on. Why? Because this I guess is 3 or 5 volts, okay. Main power on, it will be drained to GND, okay. It will be drained to GND. So here we will have 0 volts, okay. So in this case of PU5A, we don't want this with voltage, okay. We don't want this with voltage. We want here 0 volts. Why? Because this 0 volts will come to the base of PQ21, okay, and PQ21 it will not activate, okay. If this PQ29 it is not activate, okay, so the main power on, it will be not connected to GND, and here we will have all 3 or 5 volts, okay, depends on the motherboard, okay. 3 volts or 5 volts are keep present here, okay, and will be taken to 3.3 volts and 5 volts as being the enable pin, okay. I will explain later what is the enable pin, okay, because today is only for 15 and today is only for VIN voltage, okay, right here. So this was the first part of the lesson, okay. Any questions, any doubts about what was taught? Any questions? Because I will start the second part of this lesson, okay. If you have any questions, okay, just write it. If you don't have any questions, just write no, okay. And I'm gonna drink water, okay. One second, okay. I'm just drink a bit of water, okay, because it's very hot here. Okay, no questions. Okay, guys, let's continue to the second half of our lesson number 1, okay. Sorry. Okay, so this part was almost 1 hour, okay. So second part it will be shorter. I'm going to close chat, okay. Okay, now let's start seeing, okay, our charge circuit, okay. So the main function of this charge circuit is to supply the motherboard, okay, with the voltage coming from the DC jack of battery, okay. If DC jack is inserted together with the battery, this charge circuit has the function of charge the battery. So the charger IC that we will see, it's the BQ. Let me see if I can show you right here. BQ24751A. Okay, this is the IC charger that we will see in this lesson, okay. So a quick analysis of this PU4, okay. This is PU4. Let's see right here, this is PU4, okay. So a quick analysis on this CPU4. Okay, so let's see. I will not explain, okay, all 28 pins. Okay, you can just download the data sheet. Okay, it's all written there. Okay, I'm just going to speak, okay, a few things that we technicians need to know. Okay, let's start with pin 1, charge enable inverted. Okay, so this pin is active low. Okay, this pin, it is not active as 3.3 volts, 5 volts, or 19 volts. Okay, this pin is active at 0 volts. Okay, when this pin is 0 volts, okay, it will make the battery to receive the charge. Okay, so if this pin number 1 is with high value, the battery, it will not charge. Okay, sorry. Excuse me. Okay, pin number 2 and pin number 3, okay, they are the current sensors of the DC jack. Okay, every time you see AC right here, pin 2, 3, AC and ACP, pin 4, AC drive, pin 5, AC detect, pin 6, AC settings, set 7, sorry, 7, okay, AC operational. Okay, let me see more. Okay, pin 13, AC good. Let me see more. All these pins AC, okay, are concerned to DC jack adapter. Okay, right here. So pin 2 AC N, this is the current sensor of the DC jack. Okay, this is the negative pin. Pin 3 AC P, this is the current sensor of the DC jack adapter. Okay, this is the positive side. Pin 4 AC drive, okay, this is the signal that it will active the entrance MOSFETs. Okay, here in Portugal we call the entrance MOSFETs. Okay, the MOSFETs PQ7 and PQ7 and PQ8. Okay, right here. So the reverse conduction of this signal, it will block the MOSFETs PQ7 and PQ8. Okay, so PQ7 and PQ8, okay, they should be connected both, okay, at the same source. That is called a common source, right? The signal right here on pin 28 named PVCC, it will be connected on the knot, okay, on the middle of PQ7 and PQ8 right here. Okay, why it is this not connected before PQ7 or after PQ8? Okay, this pin 28 PVCC is connected on the knot of PQ7 and PQ8, okay, to assure that the logic conduction, it is always present when it is necessary. Next, pin 5. What is the pin 5 AC det or AC detect? Okay, this pin, it will sense that the adapter, that the DC jack adapter is inserted. Okay, the voltage of this adapter of this DC jack, it will be detected if this pin 5 AC detect, okay, it is bigger. It is superior. Okay, not bigger, it's superior. Okay, if this pin, if this voltage on pin 5 AC detect, it's higher, okay, than 2.4 volts, right? 2.4 volts right here. Okay, pin 6 AC settings. Okay, this AC settings, okay, it's the input pin of the configuration of the current of the DC jack. Okay, and then we have AC operational, OVP set. Okay, OVP is over protection settings, AGND analogic GND. Okay, V reference voltage reference, pin 11 VDAC voltage from this converter. Okay, digital to analog converter. Okay, it will convert zeros and ones to voltage, to 3, 4, 5, 6 voltage. Okay, then we have pin 12. Okay, voltage adjust. It's like how can I explain this? Okay, adjust is like the brightness of your computer. Okay, you can select more brightness on your screen or less. okay, brightness, okay, it's voltage adjustment, okay, you can adjust, okay. AC good, okay, it's the power good that I will explain on lesson 4 and 5 and so on, okay. So you can see all these pins, okay, and what it means, what is the function, the why and how they are here, okay, on the data sheet, okay. I only spoke about the important pin, okay. So let's continue, okay. So for all this to function, okay, it is used this pu4, okay, this charger IC, okay, for batteries Li-ion, okay. And then we have PQ7, PQ8, PQ9, PQ10 and PQ11, okay. So when the supply of 19 volts is present on the motherboard, okay, this voltage it will arrive on pin 5, 6, 7 and 8 of PQ7, okay, the drain of PQ7, okay. The PQ7 it doesn't need to be activated on this gate. Why? Let me show you, okay. Because this voltage, this 18, 19, let me just use 19 volts, okay. 19 volts, it will come to here, okay, on the drain, pin 5, 6, 7 and 8. This is called the common drain, okay, this is called the common drain. The same signal on 4 pins, common drain, and it will be present on the diode, okay. As the diode, it will not make any barrier, okay, any wall right here, okay. So the voltage it will pass, okay, with no problem on the source, okay. This is the source of PQ7, okay. This PQ7 doesn't need, okay, this gate right here, this pin 4 right here, okay, the gates, okay, to be activated, okay, right here, because the diode it will not protect, okay, it will not stop this voltage right here, okay. This is the NOT, okay, where PVCC pin 28 it will get its supply, okay, right here. And then we have PQ8, okay. Look here, as you can see, PQ7 and PQ8 not 8, I'm sorry, PQ7 and PQ8, okay, the MOSFET it's the same, okay, right here, AO alpha and omega 4707, okay, it's the same MOSFET, okay. But you can see the inside, let's see, my mouth is here, you can see the inside, the diodes, okay, and the pins right here. This is drain, okay, and the drain is on the other side, okay. And you see that it's the same MOSFET, yes, but it is soldered inverse, okay. Why? Because this kind of montage, okay, or montage, this kind, okay, of circuit, it is called the diode MOSFET drain, okay, right here. So a transistor diode MOSFET, it's a creation method of a device of rectification of 2 terminals, okay, one diode, okay, from a transistor of 3 terminals. So one specific characteristic of these transistors connected to the diode is that they are always on the saturation region, okay. As we can see here, okay, this PQ7 it's always saturated, okay, it's always functioning, okay. As we have 19 volts in here, okay, this voltage it will be present in pin 1, 2, 3, okay, even without the pin 4 gate pin receives information, okay, this voltage right here, okay, this AC driver, okay, because this PQ7 it is called a transistor diode MOSFET, okay. Because this PQ7 it's reverse, okay, it's reverse right here, okay, and he is always on the saturation zone, right. So this, oops, too much. So this signal named VIN it will arrive to PQ7 on pins 5, 6, 7 and 8, and it will be taken to pins 1, 2, 3 source of PQ7. In this point, besides we have the voltage, okay, on the source pin 1, 2, 3 of PQ7, the current is too low. Okay, we will have in PQ7 with 19 volts or 18 volts, but the current it will be too low. Okay, and this voltage it will be present on pin 1, 2, 3 of PQ8, okay, the source of PQ8. Okay, when this voltage of 18 or 19 volts comes into the source, okay, pin 1, 2 and 3, it will come to here, okay, but the diode it will make a barrier, a wall, okay, and this voltage right here it will be stuck in here, okay, and then this voltage it will try to pass to another side. How? Since the diode is making a wall right here, this voltage it will try to pass through here, okay, but as the gate it's open, okay, the voltage it will be here, and there is no voltage on pin 5, 6, 7 and 8. Okay, so as we can see, this is a PNP. Okay, this is a PNP. P, N, and P. Okay, this is a PNP. Okay, as we can see, this 19 volts, okay, it will be present in here. Okay, this 19 volts it will be present, okay, in here. You see right here, this 19 volts it will be present in here. Okay, this 19 volts it will be present in here. 19 volts 19 volts it will be present in here. As this is a PNP, okay, the gate pin number 4 needs to be low, okay, needs to be low, 0 volts. Okay, as far as we have in here on pin 4 19 volts, this PQ8 it will not saturate, okay, it will not activate itself, right, it will not activate itself. So what it needs here, okay, it needs the pin, let me just pass here, okay, it will need this AC drive right here. Where is my mouse? Okay, it will need this AC drive right here, okay, to function and put all these 19 volts to 0 volts. Okay, we will need here 0 volts. Okay, when in this point we have 19 volts and we have here on pin 4 on gate pin 0 volts, okay, this PQ8 it will saturate, okay, it will activate. When this pin when this PQ8 activates, this 19 volts it will pass for the other side. Okay, so we will have here 19 volts, 0 volts and 19 volts, 19 volts, 18 volts, whatever. Okay, right here, because here, okay, we need to have AC drive, okay, 0 volts. Okay, we see this line on the top. Okay, I will explain on the next lesson what it's this line right here. Okay, everything that you see on the schematic, okay, means something. Okay, there's nothing there just because it is. Okay, no, everything means something. Okay, right here. So both gates, okay, of PQ7 and PQ8 it will need 0 volts, okay, because it's a PNP, okay, because it's a PNP. The pin 1 of the charger IC it will receive 0 volts. How? The KBC it will send this from page 28, sorry, this signal named forced charge. Okay, this forced charge will get to PQ19. Okay, this PQ19, okay, as we can see here, okay, this is P. Okay, good practice. This is P, this is N, and this is N. Okay, good practice. Okay, so when this 3 volts first charge, 3 volts, okay, arrives to gate of PQ9 19. So with this PQ19 it will activate this 24,751 voltage reference. It will be present in here, okay, it will be present in here, okay. When these 3 volts activate PQ9, what it will happen is this voltage right here, okay, it will be taken to source or GND, okay, and here we will have 0 volts. You see, 0 volts. This resistance right here is here to protect, okay, protect what? Short circuits, okay. As soon as this first charge would arrive here on PQ19 and PQ19 would drag this voltage to GND, all this line right here would be in short. Why? Because everything would be taken to GND, okay. So this resistance right here protects all this circuit above, okay, all this circuit up, okay. The only circuit that it will be with 0 volts, it's from the terminal 1, okay, from resistor PR72 down, okay. All this area here, okay, it will be with 0 volts. This charge enabled with 0 volts, it will be taken to pin number 1 of the charger IC, okay, right here. It will be taken to pin number 1 of charger IC, as you can see at this point, okay, with 0 volts, okay. On the next lessons I will explain this hashtag. I will explain this line above the letters, okay, right here. So it will be here with 0 volts, okay. So after that, okay, we have here this PR39. This PR39, it is called a load resistor, okay, right here. This is called a load resistor, okay. So this voltage, it will cross this load resistor, okay, and it will assume it will be named of B plus, okay. This voltage B plus, named B plus, it will be taken to the various sections of motherboard. When this voltage, okay, when this battery voltage, okay, is released, this voltage, it will be taken to pins 4, 5, 6 and 7 of the discharge MOSFET, okay, PQ9, sorry, PQ9 is also called discharge MOSFET, okay, it is also called discharge MOSFET, okay. So doing our analysis, okay, right here, doing our analysis, okay, this signal called battery plus, okay, it will be present here from pin number 1 of the battery connector, okay, and we'll go to drain, okay. As you can see, okay, this diode is inverted, so the voltage, it will be present here, okay, even without the gate being activated, okay. So let me just change the color of my pen, just change the ink, blue, okay, this blue, right here, okay. So this 19 volts, it will be present here, okay, but this internal diode, okay, it will create a wall, a barrier, okay, and it will not let this pass, okay, it will not pass right here, okay. This 19 volts also, oops, now I lost, okay, this 19 volts, it will also be present here, okay, here, okay, here, as we can see by this arrow, okay, this is P, this is P, and this is N, okay. So if this is negative, if pin 4 is negative and it's receiving 19 volts, okay, this PQ9, it will not work, okay. So this PQ9 needs to go to 0 volts. That's why we have this signal named battery driver, okay, battery driver. This battery driver is 0 volts. Okay, when this 0 volts gets here, okay, and this PR41 is here to protect, okay, because when this pin 4, this gate pin, okay, gets in short and stays with 0 volts, okay, the 0 volts will only stay from this side down, okay. This resistance it will protect, so from this point up it will not be any short present, okay. Right here it will have no short present, okay. So this is battery drive that we have in here, okay. So PQ9 it will have the battery drive with 11 12 volts, okay, from 7 to 12 volts, okay, right here, but the current it will be very low, okay. For we have a good current and a good voltage, this PQ9 it will need the battery drive, okay, the battery drive to be working on, okay. Right here, let me just show you, okay. This battery drive comes from the pin 14, okay, pin 14 from PU4, it's the charger IC, okay, right here. So I'm sorry. Okay, continuing. Okay, so in this instant, okay, in this moment, okay, so we have the pin 24, okay, of the KBC now sending a signal named AC off high voltage, okay, with 3.3 volts, okay. So when this signal named AC off, AC from the DC jack, okay, when signal AC off is present on pin 21 right here, let me just show you, okay. I'm changing color because this blue is very white, yeah. Okay, that's why I use red, because red I can see better, okay. This pin 21, okay, as being AC off, okay. When this signal on pin 21 AC off is present on pin 21 of this charger IC, okay, the signal on pin 14 battery drive it will be released to the gate of PQ9. What is this AC off? This AC off means that the DC jack it's unplugged from the motherboard, okay. When this pin 21 receives the information that the DC jack it's unplugged from the motherboard, okay, the computer needs to be supplied by the battery, okay. So this battery drive on pin 14 it will be sent, this 0 volts it will be sent to pin 4 for gates on PQ9, okay, to supply the laptop motherboard with the voltage that comes from the battery, okay. When pin number 4, when gate of PQ9 gets this 0 volts from battery drive from the PU4, the charge IC, okay, the positive voltage coming from the battery, pin 1 battery, okay, it will pass through PQ9, okay, and the let me just show you, okay, PQ9 and the motherboard it will be supplied by this voltage named B plus, okay. B plus it's from the DC jack or from the battery, okay. At this point it is from the battery, okay. The voltage that it will be sent by BU4 to supply the battery, to charge the battery, okay, it will be called BATT++, okay, or battery plus plus, okay, that we can measure it on PL6 and on the load resistor PR46, okay. The pins 5, 6, 7 and 8 of PQ10 right here, okay, AO 45, AO alpha and omega 4466, like 8, it will receive this P plus voltage coming from the battery or the DC jack. This voltage it will stand still on PQ10 until this PQ10, okay, it will be here on PQ4, okay, he will receive it will receive the pulse, okay, coming from the pin 26 high drive. Okay, when the PQ10 on pin 4 gets the signal named high drive, okay, here on pin 4 of PQ10, the regulated voltage, it will be present on pin 1, 2, 3 of PQ10 on source of PQ10, okay, that it will be sent to pin 5, 6, 7 and 8 of PQ11, okay, alpha and omega 4466. Okay, so both terminals of this resistor right here, okay, are connected to pins 2 and pin 3, okay, right here. So pin 2 and pin 3, let me just okay, it's here. Okay, so pin 2 and pin 3 of PU4, okay, there are pin sensors they will sense the amplification of current, okay, on the DC jack. Okay, so these pins are used to detect, to sense the current that comes from the DC jack supply. Okay, this PU4, when you catch the signals on pins 2 and pin 3, this PU4, it will release a signal named ADPI. Okay, let me just show you. Okay, here in pin 15, okay, IADAPT, okay, something like that. Okay, okay, this IADAPT, okay, it means current that comes from the adapter. Okay, here on pin 15. Okay, so the signal, it will come out, okay, on pin 15 right here of PU4, okay, named as ADPI, as you can see right here. Okay, that it will be taken to pin 64 of KBC on page 28, as you can see right here. Okay, on page 28. So for this PU4, okay, this BQ24 whatever, okay, this charger IC, okay, the function, this PU4, it will need to receive the voltage pin, okay, coming from the DC jack or the battery on pin 6. Okay, right here, let me just show you. Okay, on pin 6. Okay, let me see. Oh, no, this is next lesson. Okay, this is 3.3 volts and 5 volts. Okay, this is next lesson. Okay, and I told you that this lesson is only about 19 volts. Okay, so this is lesson number 1. Okay, this is lesson number 1. Okay, any questions about this second part and first part? So, any questions about this first part and second part? Ok, then, então, so, my Portuguese with English. Okay, then, so I hope that everyone, okay, had a great time, had enjoyed, okay. See you tomorrow on lesson number 2. Okay, that I will teach step by step 3.3 volts and 5 volts, okay, how it works. I will teach, okay, inside the regulator IC, okay. I will teach how it starts, the sequence of we can measure a regulator IC, okay, so you always will know how to measure, okay. All the voltage that you will expect, okay, all the calculus, okay, all my lessons, okay, I will have calculus, okay, because it is very important to have calculus, okay, so people understand the why, the when, the how become like this, how become like that, okay. So see you tomorrow for lesson number 2. Okay guys, so I will go. Okay, bye, see you tomorrow.